Hi guys! So as many of you already know, I manufacture these contact microphones and I shamelessly sell them over on my website, and I'll put a link down below. Um, and so these microphones, like all sensors, have a limitation in their dynamic range. And so today I want to show you an algorithm that I came up with that composites together recordings from two microphones to produce a recording that has a higher dynamic range than either microphone by itself, in a way that is similar to high dynamic range photography. So let me try to explain the dynamic range issue a little bit more. So these microphones output a line level signal, which is about plus or minus 1.5 volts maximum. So that puts a limitation on how loud of a sound you can record. If you record a sound that produces more than 1.5 volts plus or minus at the output, then that sound is going to be clipped at plus or minus 1.5 volts. Of course, if you want to record a louder sound, you could always select a microphone with a lower gain, and that would give you more headroom for recording loud sounds. But then if you wanted to record really quiet sounds, the sound would be lost kind of down in the noise floor of the microphone. So this is similar to how in photography, you can't record something very dark at the same time as something very bright, because you fundamentally need different recording setups or different camera configurations or different microphones to record things that are very high intensity and things that are very low intensity. So I'd like to make an audio recording to illustrate this further. And so what I've done is I've put two microphones on my guitar. And this one is the original red model Metal Marshmallow, which in general is going to be way too loud, or the gain is way too high for recording guitar. Okay, and then I also have this, which is the new Unity gain model, which will actually have green heat shrink on the production model. And this one is about 24 decibels lower than this one, and might actually be a little too quiet to record some of the softest sounds I want to make. And so these microphones are going into my audio interface, and I just have the levels set appropriately for each mic. And then that goes into my laptop where I'm recording with Reaper. Okay, so now I'm going to play the guitar, and what you'll see first, I'm going to play the most extremely quiet thing that I can possibly play. I'll really just be barely touching the strings at all. It'll be almost inaudible. And then I'll play the most extremely loud thing that I can possibly play, really just kind of slamming the guitar strings with a pick. Okay, so let's take a look at this. So I have the high gain mic on top and the low gain mic on the bottom, and the quiet section is over here and the loud section is over here. And so right off the bat, we can see that during the loud section, the high gain mic is just absolutely clipped to hell. I mean, this sound is way too loud for the high gain mic. And we can listen to that just to confirm that it sounds like garbage. Okay, so that's not too surprising. But if we look at the lower gain mic, we can see that that looks pretty good. It doesn't appear to be clipped at all. The level looks about right. And we can listen to that one. So that sounds fine. So clearly the lower gain mic is the better microphone for recording these very loud sounds. But so now let's look at the quiet section, which is in fact so quiet that it really even barely showed up as a blip on either microphone. But so in order to look at it a little bit more, maybe I'll just cut this part off and then normalize it. And I'll do that to both microphones. So they should be kind of at equivalent levels now. And so first let's listen to the low gain mic. So you can hear there's a very high noise floor there, and the actual sounds that we're interested in are competing with the noise. Although I will note that most contact mics hum very prominently at 50 or 60 hertz. And so here it's nice to hear that this noise floor is completely hum-free. So let's listen to the high gain mic. Okay, so there's barely any noise at all, and in general it's just a much more sensitive and kind of intimate recording. So even though I was really just barely even touching the guitar strings, here it just sounds like I'm playing normally. So I think it's fairly clear that the high gain mic is better for recording these very quiet sounds, and the low gain mic is better for recording these very loud sounds. And so what I would like is an algorithm that can composite together these two recordings. And I'd like that algorithm to select the quiet sections from the loud mic and the loud sections from the quiet mic, so that I end up kind of with the best of both worlds. Similar to how in photography, you can composite together an overexposed image and an underexposed image in such a way that the whole image is properly exposed. So there are probably several different ways that I could do this. In fact, this is such a simple recording that I could easily just manually draw in the crossfade curve that I want here. Or if I wanted something a little more sophisticated, I could gate this mic and use that to duck this mic. And that would at least kind of crossfade back and forth between these mics in the desired way. However, we can also do a little bit better than that. And so I'm going to show you how to do that. And so just as a pre-processing step to what I'm about to do, I need these mics to be about the same volume. And so what I'm going to do is normalize the lower mic. And then I'm going to adjust this higher gain mic until its amplitude is about the same as the lower gain mic in a place where it's not clipping. So I can play this and watch the VU meter and see that this is about 18 or so decibels too high. So if I lower this by about 18 decibels, then the outputs should just about match. So now what I want to do is break both of these audio files down into individual frequency bands and apply the crossfading that I want individually to each frequency band. And that's because most natural sounds behave differently at different frequencies. And so what I have here are spectrograms from a couple of different little blips of audio taken out of the high gain mic recording. And so this is amplitude on this axis plotted as a function of frequency on this axis. And this top line up here represents kind of the loudest usable sound from the high gain mic, or it's the loudest sound before that mic starts clipping. And then this other line down here is kind of the quietest part of the recording, or at least it's from a part of the recording below which I consider the low gain mic to be unusable because of the noise. And so you can see that both of these curves resemble something that looks like a plot of negative log f or something like that, with most of the energy concentrated in the low frequencies down here and much less energy in the high frequencies up here. And this is well known to be characteristic of most natural sound. And so if you want some kind of threshold for determining which mic you're going to use, this kind of demonstrates why you can't just use a flat threshold, because almost no matter where you put the threshold, the low frequencies will be above the threshold and the high frequencies will be below the threshold. And that's true for both very loud and very quiet sounds. And in fact, these are the thresholds that I'm going to use. And so the way that this works is I look at the high gain microphone. So at a given frequency, if the amplitude of the high gain mic is below this blue threshold, then I will just select the high gain microphone. But if it's above this higher orange threshold, then I'll select just the low gain microphone. And if it's somewhere in between these two thresholds, then I'll use a mixture of both microphones. So in other words, as the intensity of the high gain microphone increases from here to here, I will gradually crossfade from the high gain microphone to the low gain microphone. Okay, and these thresholds are different for different frequencies. And that's going to allow me to combine the louder sound of the guitar from the low gain mic with the quieter noise floor from the high gain mic. And we'll see that in just a moment here. Okay, so I wrote an algorithm that does that, and I'll put a link below to the GitHub repository where the code is in case any of you want to play around with it. And so down here, I have the output of that algorithm. And just as a sanity check, you can see that here in the loud part, I got the output from the low gain mic, which is what I wanted. And I can just play that to make sure it sounds like I expect. Okay, so that's fine. And now let's look at the quiet part here. So again, I'll just split these off, and then I will independently normalize each one of these. And just to refresh our memories, I'll play first the low gain mic, which has a high noise floor. And then I'll play the high gain mic, which is what we want. And then I'll play the composite so we can hear what we got. So that sounds perfect. It's exactly what we wanted. We got the low gain mic from the loud part and the high gain mic from the quiet part. Okay, so now let's look at what happens at the end of this recording, because obviously we're starting with the low gain mic here on this last chord, but we're also fading out to silence, so we want to crossfade back over at some point to the high gain mic. So to look at this in a little bit more detail, I'm again going to just cut the end off here and normalize independently each one of these. And so let's listen first to the low gain mic, which we expect to have a higher noise floor. Although this recording does have a nice, beautiful low frequency response. Okay, then let's listen to the high gain mic. That actually sounds really nice. We can hear all of these kind of little sounds that we wouldn't normally hear. And then let's hear what we got in the composite. yeah, so we got exactly what we wanted. We started here taking from the low gain mic, and at some point we crossfaded over to get just the output from the high gain mic. And so we can confirm what's happening by looking a little bit at the behavior of the algorithm. And so here I'm kind of looking at what happens at the 689 hertz frequency band. And this line is telling me how the mics are being mixed together over time throughout the piece of music at that specific frequency. And so it's not surprising that we started here with just the high gain mic all the way until the moment that I play that first really loud chord, at which point we immediately switch over to using just the low gain mic and pretty much just stay there until after I've played the last chord, and then we gradually fade back over to the high gain mic. So that's exactly what we would expect. And so now we can also look at a different frequency band. So the blue line here is the 6,891 hertz band. And it does almost exactly the same thing, staying low and immediately shooting up. However, this band, every time I play one of these loud chords, it starts, as soon as it can, it starts crossfading over back a little bit towards the high gain mic, or mixing a little bit of the high gain mic back in. And that's good because most of what lives at this frequency band is just noise. So, in other words, after I strum the guitar, as soon as it can, it's trying to go back over and take the lower noise floor out of the more sensitive microphone. Okay, so that's all fine and dandy, but of course this is a trivial piece of audio, so why don't we see how this algorithm performs with a more realistic piece of music that has some interesting variations in loudness and softness. Okay, so this is what the recordings look like. Again, I have the high gain mic on top and the low gain mic on the bottom. And just as before, you can see that in some of the louder sections, this high gain microphone has clipped. And again, that's not surprising. And also you can see in some of the quietest sections, the music is really just buried in the noise floor of the microphones. And so I've used my algorithm to create a high dynamic range composite. And so this is what that looks like. And just as a sanity check, we can see that it is not clipped during the loudest sections, so that's good. And then we can look here at the behavior in the quietest section, or one of the quietest sections. And again, I'll just split that off and kind of independently normalize each one of these so we can hear what we've got. And again, let's start by listening to the low gain microphone, which should have a higher noise floor. And then the high gain microphone. Again, a nice, clean, sensitive recording. Now the composite. Okay, and so what's interesting about this is that just by looking at the composite waveform, it looks more like the low gain microphone. but it sounds more like the high gain microphone. And that's because what the algorithm has done is it's taken some of the guitar sound from the lower gain microphone and mixed that in with the lower noise floor of the higher gain microphone. And so we get this kind of composite that has the best of both worlds in some way. And so this composite recording also has some artifacts in it. In fact, if you listen closely, you can hear the noise floor kind of coming in and out or raising and lowering in volume as the mix changes. And you can hear that pretty clearly towards the end here. And so maybe what I'll do is clip off the end of this and then normalize it so you can hear it more clearly. Okay, so you might have to listen with headphones to be able to hear that, but as the audio fades out, you can really hear the background noise also fading out and then coming back in a little bit when I play the last little chord and then fading all the way out. So that might be undesirable in certain situations, but there's also something satisfying about hearing that noise just vanish. And now I know if I wanted to, I could really amplify the tail end of this recording without burying myself in noise. And so if we look here at the behavior of the algorithm again, we can see that it's much more complex than it was in the previous example. And you can see that the algorithm is really kind of continually cross-fading back and forth between the two microphones. Almost every single time I play a note or a chord, the algorithm kind of switches over and grabs some from the lower gain mic. And then as that chord fades out, the algorithm then kind of fades back over to the high gain mic. And again, if I look at this 6,891 hertz band, again, the behavior is much more complicated with this kind of continual fading back and forth. Okay, so now what I'd like to do is add some dynamic range compression to the audio and a little bit of reverb. And then let's go ahead and listen to what this HDR recording sounds like. So overall, I'd say that actually sounds quite nice, especially considering, that this is like a $50 guitar. The guitar actually doesn't really sound that nice in person. Yeah, the recording is actually, in a way, it's quite intimate. You hear all of these little kind of string noises and fret noises are amplified more than they might be in another type of recording. It's almost like listening to someone humming to themselves in the shower, except your ear is like right next to them. Yeah, there's something I think that is really nice about a recording like that. So overall, I'd say this high dynamic range algorithm is working fairly well. Although perhaps there are some improvements that could be made in the future. It would be really nice if somebody wants to bundle this into a plugin or something like this so that you could just use this kind of in real time in your digital audio workstation. Also, as I mentioned, the main kind of artifact with this technique is that if you listen really closely, you can hear the noise kind of fading in and out. So it might be interesting to experiment with some noise reduction as a pre-processing step. And furthermore, it might be interesting to experiment with trying to automate some of the pre-processing, trying to make sure the audio files are both the same loudness and so forth. But anyway, I think that's all I have to say about that for now. So if you want to, you could maybe subscribe to me, or you could go buy a microphone on my website. I mean, look at this. It's beautiful, beautiful. How could you not want this? Anyway, that's it. So I guess I'll see you next time. Bye!